Welcome to welcome to the first lecture of computer organization course at Shepherd University. We will talk about computers and the different type of architectures of processors, and I use the textbook The Essential of Computer Organization and Architecture, 5th edition by Linda Knoll. And we have PowerPoints, and we also use OneNote to uh, teach. The first thing I want to talk in this course is the difference between computer organization and computer architecture. Okay, then we want to know what is the differences between when we talk about the computer organization, what do we mean, and when we talk about computer architecture, what we want to focus on. Then we will discuss the different units of measure in computer systems. So there are different units that we use to specify and discuss and determine the different parameters of computers. We will discuss those units. Then we will talk about the evolution of computers, and after that I will show you and discuss the computer as a layered system, as a like hierarchy leveled layered system. And after that we will discuss the von Neumann model of computers and the architectures that was introduced by von Neumann. These are the objectives of the first chapter of this textbook. Okay, but first we should answer to a question why we need to study computer organization and computer architecture. Why we actually need to, is there any reason we study these subjects and these materials? Yes. The first reason is to design better programs. When we know how does a computer work and what are inside the processor, what is the architecture of a processor, how does the processor moves the data and the signals inside the memory and the other components of the computer. If we have all this information, of course we can design a better program. Without knowing the concept of computer organization and without knowing how does a processor work, definitely we cannot write a good program. So of course, the programs such as compilers, operating systems, and device drivers are very important and very dependent to architecture of a processor. So in order to write these kind of programs, we need to be familiar and expert in architecture of these computers. Then we can optimize the behavior of our program, so we can just minimize the path of data movement in the processor and reduce the number of instructions needed to be executed for running a program, or optimize the program behavior to make it faster and shorter. Okay, so a smaller program which is faster, of course, is the best. So how we can do that? By getting familiar and expert in designing an architecture of a computer. Then we need to know about the organization and architecture of the computer to evaluate computer system performance. Without knowing the inside of a processor, how we are going to write a benchmark program to evaluate the performance of this computer. And last not the least is understanding time, space, and price trade-offs. So time and price are very important. Space also is important, but not as important as time and price. So by gaining time, we might lose price. Sorry, by reducing the price, we might increase the time. And for in order to decrease the time, we might have to pay more. Okay, so by knowing the inside architecture of a computer, we can understand these trade-offs between time, space, and price. Okay, but we talked about computer organization and computer architecture as the same concept so far, but what is actually difference between these two uh, concepts? What is difference between computer organization and computer architecture? Computer organization covers all of physical aspects of computer like circuits, control signals, memory, I/O, display, input, mouse, and different type of interface and components of the computer. And what we learn in computer organization, we learn how does a computer work. So in computer organization lecture, we will learn how does a computer work. But in computer architecture, we talk about the logical aspects of the system like instruction sets, instruction formats, data type, addressing models, and different architectures of different part of the processors. And what we learn in computer architecture, we learn how to design a computer. So, if someone asks you what's the difference between computer organization and computer architecture, you can simply say in computer organization you learn how does a computer work, while in computer architecture you learn how to design a computer. Okay, there is one important definition in computer systems, and it is principle of equivalence of hardware and software. What does it say? Anything done by hardware can be done by software, and anything done by software can be done by hardware. So here says any task done by software can also be done using hardware, and any operation performed directly by hardware can be done using software. But what's the difference? Let me tell you. If we have software and hardware, of course, software, we have some like trade-offs. Let's go back and look to these trade-offs. Time and price. Okay, time and price. So let's see, time, okay, software, hardware, time, and price. Of course, software is cheaper than hardware. Okay, software just is code. So price is low in software, price is high in hardware. But on the other hand, software is slower. So time is higher in software and is lower in hardware. And here is a trade-offs. So one of them like costs more but it's faster. The other one costs less but it's slower. and we should design as an engineer which one we prepare. Okay, what are the main component of each computer? Each computer is consists of, in the simplest possible definition, a computer consists of three pieces. Okay, the first is the processor, which is the brain of a computer. It has a memory and it has a mechanism for transferring data. Because without a mechanism for transferring data between the computer and the outside, we have absolutely no idea about what the processor is doing. We cannot like enter information to the processor, and we cannot read the output and the results of the process. So we need a mechanism for transferring data. We need a memory to store information, and of course we need the processor as a brain of a computer. Okay, so these are the most important and basic components of each computer. Okay, here I want to show you one advertisement. We can find it online in your email or website. They advertise a computer. We want to see what parameters that they show and they give us as information, and what does they mean. Okay, so what does cache means? What does L1 cache, L2 cache? What is PCI? What is gigahertz? What is gigabyte? What is USB? Okay, so I will explain all of them one by one in this advertisement. Okay, let's move to the next slide and see what's the difference between each advertisement, each line. But before discussing this advertisement, let's learn about some units. Okay, about some units in computer. So first, we want to measure the capacity and speed. Okay, we have some units. We have kilo. Kilo is 1000. We show it with capital K, and it is equal to 10 to the power of 3 or 2 to the power of 10. So it's very important to know that 10 to the power of 3 is equal to 2 to the power of 10. The next one, the next level is mega. Mega is 1 million, and it is 10 to the power of 6 or 2 to the power of 20. Why I talk about 2? Because 2 is the most important base in computer systems. Then we have a gigahertz, giga, which is 1 billion, and it's equivalent to 10 to the power of 9 or 2 to the power of 3, and we can continue. So the first four are more important: kilo, mega, giga, and tera, and we can continue to peta, exa, zeta, iota, and so all of them are the units, but the first four units are the most important, which we usually use. But don't forget, 10 to the power of 3 is equal to 2 to the power of 10. So it says that if you multiply 2 10 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's equal to 1000. It's not exactly 1000. It is equal to 1024, which we consider 1000. So 10 to the power of 3 is also equal to 1000. Okay? 10 to the power of 6 is 2 to the power of 20. 10 to the power of 9 is 2 to the power of 30, and 10 to the power of 12 is 2 to the power of 40. Okay, these are some metrics, and For example, 1 megahertz. What is hertz? Hertz is the measure of speed, okay, frequency. So clock cycle per second. Hertz is clock cycle per second. So if we have a signal like this and it repeats itself like this, 1, 2, 3, we see that the signal is repeating. We want to see how many times this signal is repeating per second. We call it frequency and the unit is hertz. Okay, so megahertz, 1 megahertz is 10 to the power of 6, which is 1 million. So if a signal, frequency of a signal is 1 megahertz, it means that this signal is repeating or it's just changing with a frequency of 1 million hertz or 1 million hertz, or it changes 1 million time per second. Okay, so processor speeds are usually measured in megahertz and gigahertz. Nowadays, most of the processors are in gigahertz. Okay, so older processors are in megahertz. Okay, so but how we can store some data? Okay, so we use a unit called byte and bit. What is bit? Bit is the smallest unit. So bit has two values. It could be either 0 or 1. Bit is 0 or 1. If we put 8 bits next to each other, for example 1 0 0 1 1 0 1 1, so it's 8 bits, we call it 1 byte. So 1 byte is consists of 8 bits. So byte is the unit of storage. Why? Because we store these values, these zeros and ones. Okay, we will talk about bit and byte in more details in the next chapters, but for now, let's see how we can refer to this uh, unit. So we know that 1 kilobyte, which is 2 to the power of 10 byte, as I said, it's 1024 bytes. 1 megabyte is 2 to the power of 20 bytes, which is 1 million bytes. And 1 gigabyte is 10 to the power of 2 to the power of 30, which is 1 billion bytes. Okay, so we ignore, not ignore, just when we just refer to this value, we just refer to the highest digit. So it's 1 kilo, 1 meg, and 1 gig. Okay, so these numbers are not exactly 1 gig. It's 1 gig, 99 million 5. Yes. It's 1 gig is 2 to the power of 30. In fact, it's not exactly 1 with 9 zeros. Okay, so it should be 9 zeros, not 12 zeros here, because we know that 1 gig is 10 to the power of 9. So it has 9 zeros, but here I see 1, 2, 3, 4, 12 zeros. Okay, so this one is not correct. So, okay, main memory, which usually we refer to it as a RAM, is measured in gigabyte. It's the measure of memory. And disk storage is measured in gigabytes or terabytes. Okay, so gigabytes, we know that it's 10 to the power of 9, and terabytes is 10 to the power of 12. Okay, uh, so we talked about the units which are greater than 1, so 1000, 1 million, 1 billion. What about the units less than 1? We have 1 milli. Milli, we show it with lowercase m, is 1,000th. So it's 10 to the power of negative 3. 10 to the power of negative 3 is this number. Okay, 10 to the power of negative 3. Micro is, we show it with mu, and it's 10 to the negative 6. Nano, we show it with n, it's 10 to the negative 9. And pico is p, it's equal to 10 to the negative 12, and we have femto, atto, zepto, and yocto. The first four are more important, so you should make sure that you know all these units: milli, micro, nano, and pico. So if you are asked what is 1 nanosecond, you should say it's 10 to the power of negative 3, negative 9. Excuse me. Okay. So what is 1 millisecond? Milli, I said that it's 1 to the power of negative 3. So 1 millisecond, it's 1,000th of a second. Okay, so hard disk drive access time. So hard drive, we all know what is hard drive. Hard drive access time is often 10 to 20 milliseconds. So when we want to access to a data in hard drive, it takes usually 10 to 20 milliseconds. Nanoseconds is 1 billionth of a second, and it is the main memory access time. We have the main memory in computers. We have different types of memory. We have hard drive, we have CD, DVD, cloud storage, we have main memory, we have cache registers. We will discuss all of them one by one, but now as an introduction, we know that the main memory access time is about 50 to 70 nanoseconds, and micrometer is 1 millionth of a meter, which is the size and scale of processors and chipsets that we design. They usually are in the like the range of micro or nanometer. Okay, what is what is the relationship between frequency and the period? The frequency is the frequency is tells us that how many times a signal is changing per second. How many times the signal is changing per second. Okay, period says that how long does it take for a signal to change. Okay, so frequency is 1 over period. So if frequency of a signal is 10 hertz, it means that it changes 10 times per second. So how many seconds it takes for one change? 1 over 10. So period, which we show it with t, is equal to 1 over 10 seconds. Here we have the same information. It says that the bus operating at 133 megahertz has a cycle time of 7.52 nanosecond. Why? Because 1 over 133 megahertz is equal to 7.52 nanoseconds. Okay, so it's like the relationship between the frequency and period or clock time. So in computer engineering, the period is referred usually as cycle time. Okay, so the frequency and cycle time are have a relationship in this form. The frequency is equal to 1 over 1 cycle time. Okay, now let's go back to our example and advertisement. So the first line of this advertisement, if you look, you see that it says that it is a compact computer. Okay, compact computer, it means that every part has been assembled in the factory and we get the entire system as a package. Okay, because we also have the option to buy each individual devices and assemble them and put them together and build a computer. But in compact form, it means that all of the components are already put together in a factory, and we what we get as a product is a compact form of computer. The second line talks about the processor. It says that the processor is which we know it's the brain of a computer. It is a i7 quad core, and the frequency of it is 4.2 gigahertz. Okay, the frequency. So the frequency of this processor is 4.2 gigahertz. So if I say what's the cycle time of this processor, you simply can say cycle time is 1 over frequency, which is 1 over 4.2 gigahertz. And this gives us the cycle time. Okay, so now before talking about the advertisement in terms of memory, let's see what type of memories do we have in a computer. We know that the computers with larger memory can run larger programs, of course, larger memory, larger programs, and smaller memories like smaller programs because there are not enough room for big programs. But usually for modern computers, we always have large enough main memory. Main memory is called RAM, RAM. RAM like stands for Random Access Memory. What does random access memory means? It means that the memory content can be accessed directly if we know the location. So if this is a memory has different location and the data are stored in this location. If we know the address of the like data, we can directly access to that data. Okay, so this one is RAM. The other concept we want to talk is cache memory. Cache memory is like a memory which is very fast, and it is faster than RAM, and the processor uses like a cache to get access to the information faster, but it's very small compared to the RAM. It's very small, so we cannot load and store all data in the cache. So we have to put the data in the main memory, and any small part of those data that we need, we put it in the cache, and the processor accesses the data from cache very fast and quick. Okay, so let's back to our system. This system has 32 gigabyte of DDR4 RAM, and of course it has cache memory. The cache memory, it's if you look, you see that it says L1 and L2. We have two different levels of cache memory, which we discuss later in semester. But here it says that this processor has 128 kilobyte of L1 cache and 2 megabyte of L2 cache. Okay, these are the memories of these processors, like main memory and cache memory. But still, we have more memories, storage. We have hard disk storage in this computer. Hard disk storage with the size of 1 terabyte and 72 RPM. Okay, why RPM? Because how does the hard drives work? They just have a disk that rotates and the data stored on a disk. So this 7200 RPM shows the rotational speed of the disk. But recently, in the past new years, we have a new type of flash hard drives that they don't use like these disks, so they are faster, but of course faster and more expensive. We have, uh, in fact, for the memory, for the hard drive, it says that it is SATA. It stands for Serial Advanced Technology Attachment. It's the connections, the type of connections between hard drive and the memory and the computer. And the other storage device that we have is the DVD on this computer that can store up to 4.7 gigabyte. But recently, if you notice, the new laptops and computers, they not coming with a DVD because usually we use a flash drive or we download the programs from the internet. The connection speed of internet is becoming faster and faster, so we actually don't need to have disk drives, and we can easily download anything we need from the cloud on internet. And also we can use flash drives that is faster than DVD, so we can use like a flash drive for data storage. And then it shows the ports. Of course, ports are very important because ports are the interface between the system and external devices and environment. This system has 10 USB ports and a serial port and expansion slots, and so it has different types of IOs. And what is difference between serial port and parallel port? We know that the serial port sends the data as a series of pulses. So if we have this information, let's say 1 byte of information, okay, if we want to send this data to serial port, we need first send one, then this one, then send 0, then send 0, then send 1, 1, 0, 0, 1. So all these data move one by one. Okay, they are not able to move together. But in parallel ports, we send all this information once together. Okay, so we have, instead of one line, one wire to send this data one by one. You see, we send it one by one. We have, for example, 8 wires, and we send all this data at once. Okay, we send them together. So which one is faster? Of course, parallel. But what's the disadvantage of parallel compared to the parallel? Of course, it's more expensive because we need 8 wires instead of one wire. Okay, so parallel ports send data as a single pulse, okay, with at least 8 data lines, because we need 8 data lines, but in serial we need one data line. What is the USB? USB is a universal serial bus. It is a serial interface, and it is self configurable. So it is like we call it plug and play. So USB is a serial port which is self-configuring device. Okay, so if we go to the next line, we see that we have a PCI peripheral component interface, which we connect usually different cards to it, like a VGA card, sound card, and other devices that are connected to the processor. So we use PCI, and of course this system has two PCIe which is PCI Express for video cards, and sound cards, which is faster than PCI. Okay, then we have a LCD monitor here. It shows the resolution of the monitor, which is 1920 times 1200, and other information. And here we have 1 GB PCI Express video card. It shows the memory of the VGA card or video card. More memory on video card make it faster. And this system also can be connected to the internet using Ethernet cable, which it says it is uh, able to connect up to 1 gigabit per second speed. And it also has the card reader that allows like for connecting the Bluetooth devices and other components. Okay, so we learned about different definitions and the basic of computers, and if we uh, have an advertisement of a computer, what does each line mean, so we know that we at least have the basic information about a computer before starting the main discussion. Okay, I will continue in the next lecture about the standard organizations.